You've got a containerized service and three obvious places to run it on Azure: App Service, Azure Container Apps, and Azure Kubernetes Service. Every team argues about this, and most pick wrong because they compare features instead of control. In the next 5 minutes, I'll give you the mental model, show you what each one actually does under the hood, how their autoscaling really behaves, and the production gotchas that bite people. By the end, you'll know which one fits your workload without a 40-tab spreadsheet. This changes fast, so confirm specifics against current Azure docs before you commit. Think of these three as one axis: how much of the platform you operate. App Service is the highest abstraction. You give it code or a single container, and Microsoft runs the operating system, the runtime, patching, and load balancing. Azure Container Apps, ACA, sits in the middle. It's serverless Kubernetes you never see, built on a managed Kubernetes event-driven auto-scaling engine. AKS is the bottom. You get real Kubernetes API servers, node pools, and the responsibility that comes with them. More control downward, more toil downward. Pick the highest level that still meets your requirements. App Service runs your app on a pool of pre-provisioned virtual machines called the App Service plan. You pay for that plan whether or not traffic arrives, and your scaling is basically adding or removing instances of those VMIs. It shines for classic HTTP web apps and APIs, built-in TLS, custom domains, deployment slots for blue-green swaps, and easy authentication. The trade-off is the model. It assumes a long-running web server. Background workers, event-driven jobs, or anything needing fine-grained microservice networking start fighting the abstraction. No native scale to zero on dedicated plans either. Container Apps hides a managed Kubernetes cluster behind a Container Apps environment. Inside that environment, you deploy revisions, and traffic splitting between revisions gives you canary releases for free. The real magic is the scaler. ACA embeds KEDA, so it scales on HTTP concurrency, queue depth, or any custom metric, all the way down to 0 replicas when idle. It also bundles Dapr, the distributed application runtime, for service discovery, PubSub, and state. You get microservice patterns and event-driven scaling without ever touching a kubectl command or patching a node. AKS gives you a real Kubernetes control plane that Microsoft manages, but you own everything above it. Node pools, the container network interface, ingress controllers, upgrades, and the full ecosystem of operators and Helm charts. Choose this when you genuinely need Kubernetes. Custom schedulers, daemon sets, service meshes, GPU workloads, or strict multi-tenant isolation. The cost is operational. Someone on your team owns cluster upgrades, node patching, capacity planning, and a much larger security surface. If nobody on the team can confidently debug a failing pod's networking, AKS is a liability, not a feature. Here's where the bill diverges. App Service charges for the plan continuously, so it's predictable, but you pay for idle capacity. Container Apps bills per second on actual usage and scales to 0, which is excellent for spiky or bursty workloads, but can cause cold start latency on the first request. AKS nodes run and bill until you scale them down, and the cluster autoscaler reacts in minutes, not seconds. As a rule of thumb, steady, predictable traffic favors App Service, bursty or event-driven favors Container Apps, and large heterogeneous platforms justify AKS. Always check current pricing tiers. A few things bite people. On App Service, deployment slot swaps don't warm up app caches, so you can swap into a cold instance and spike latency. Use slot warm-up settings. On Container Apps, scale to 0 kills long-running background work unless you keep a minimum replica count, and the KEDA polling interval means scaling isn't instant. On AKS, the classic outage is forgetting to set pod resource requests and limits, then watching the scheduler pack nodes until they get evicted under memory pressure. None of these are bugs. They're consequences of the abstraction you chose. Here's the takeaway. Default to App Service for a straightforward web app or a PI with steady traffic. Reach for Container Apps when you're running microservices, event-driven workloads, or want serverless scale to 0 without owning a cluster. Only adopt AKS when you have a concrete Kubernetes requirement and a team that can operate it. The honest opinion, most teams reaching for AKS would ship faster on Container Apps. Start at the highest abstraction, drop down only when something forces you. and verify the current limits and pricing in the Azure docs before you build. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.